The next thing we look at is coal. Coal. Coal is a black impure carbon that is formed from vegetation that is buried under the earth for many million years. That is our plants and our animals that has died for a very long period of time and have been buried under the earth. And you know, under the earth the temperature there is high, and this dead plant and animal remains that is under the earth will be heated by what? By the temperature that is in the earth. It will be heated, and by so doing there is a formation of what? There is a formation of what? Of a very hard and black rock called what? Called coal. That is how coal is formed. It is formed from plants and dead animal that has long ago died and has been buried, and by so doing the temperature in the earth eats them and they become hard and black, and this has formed what is called coal. That is why we say it is what? Black and hard rock, which is now known as coal. Now, what are the uses of coal? It is used as a domestic fuel in our houses for cooking. As a domestic fuel, it is used for what? It is used for cooking, for doing various of things, because it gives a source of heat when ignited. The next one is that it is used in power station for generating electricity. In power station, before they can make their engines to work, they use coal to power it. The next one is what? In railway station, and the locomotive of the engines of railway work on coal. The railway that is working, the engine needs coal to work. The next one is what? In the manufacture of many chemicals and drugs in industries. Now we have types of coal. We have the peat, the lignite or the brown coal. We have the bituminous, or you call it the soft coal. We have the anthracite, or you call it the hard coal. Now, peat is not a true coal, because it is the first stage of the formation of coal. The first stage. So you cannot just call it a coal, because it has not yet formed anything, and it has 50% of carbon in it. So it's not a true coal. The next stage is is lignite. Lignite can also be called a brown coal. Another name for lignite coal is a brown coal. That lignite contains 60% carbon. 60% carbon. Then the next stage is bituminous. Bituminous coal can be called a soft coal. Soft. Bituminous can be called a soft coal, and it is the most plentiful. The most plentiful, and it has 80% of coal. Bituminous is what we found everywhere. It's very plenty. So it contains 80% of carbon. Anthracite is the final coal formation. The real coal is anthracite, because it's the fourth stage of formation of coal, and it has over 90% of carbon. It has over 90%, so it is the oldest form and the hardest form of coal. That is why we call it the hard coal. The next thing we look at is destructive distillation of coal. Destructive distillation of coal. What is not destructive distillation of coal? It means that when you subject coal to heat, what are the products that it will give? Now, when you subject coal to heat that is more or about 1250 degrees Celsius, you are going to get some products, and the products are they are coal tar, coal gas, ammonium liquor, and coke. Now, the process by which you subject coal to heat to give this product is called destructive distillation of coal. By the time you subject coal to a very high temperature, they are going to give these four products: coal gas, coal tar, ammonium liquor, and coke. Now let's look at the meaning of all these products and their uses. The first one is what is coal gas. Coal gas is a mixture of some gases which are ethane, methane, carbon dioxide, hydrogen, sulfur oxide. That is, the sulfur oxide is very small, and hydrogen sulfide very small. Now coal gas contains all this. Now don't forget that coal gas is what is part of the what destructive distillation of what of coal. Now by the time you subject your coal to a very high temperature, now this coal gas is a volatile coal. It is volatile. Now this coal gas, coal tar, and ammonium liquor, these three, they are volatile. After subjecting them to heat, the only one that is non-volatile is coke. Coke is non-volatile. That one will be left, and all these three will be collected at different temperatures. Now the first one, which is what coal gas, has methane, ethane, carbon dioxide, hydrogen, sulfur oxide, that is very small in small quantity, and what hydrogen sulfide in what small quantity. Coal gas is used as a fuel. It's used as a fuel commercially for cooking also. That is what coal gas. The next one is what is coal tar. Another product of what destructive distillation of coal is coal tar. Don't forget that I said destructive distillation of coal is the process by which you subject coal to a very high temperature to give what? To give some products which are coal gas, coal tar, ammonium liquor, and what? And coke. And these three are what? Are volatile. Now let's move on. We have coal tar. Coal tar is a thick brownish black liquid. Now this thick browny what? Black liquid, it has a mixture of what? A mixture of so many organic compounds, which is what? That is coal tar. Now these organic compounds which is contained in coal tar are toluene, naphthalene, benzene, phenol, and so on. All these organic what? Compounds or chemicals are found in coal tar. Are found in what? In coal. Now your coal tar is used in the production of what? Of many other chemicals. Many chemicals like your disinfectants, your dyes, your disinfectant dyes, and so many chemicals. Also, it can be used to produce chemicals that are used in the what? In the laboratory. Now the next one is what? Ammonium liquor. The ammonium liquor is made of what? Ammonia and water. Ammonia and what? Water. They dissolve ammonia in water. That is where we get what? Ammonium what? Liquor. And don't forget that it is also volatile. What you know of volatile? It means that it can escape. It can escape to the atmosphere. It can escape when it is being open. Any substance that when you open it and it escapes. That you call them what? A volatile substance. Like your spirit now. When you open methylated spirit, you are going to find out that the molecules of these methylated spirits, the ones that are active, will start escaping into the atmosphere. Now the next one we are talking about is what? Is ammonium liquor. It's also a volatile a volatile product of what? This destructive distillation of coal. Now I said ammonium liquor is what? Ammonia in water. Don't forget that our ammonia is what? NH3. And this ammonia in water is used for the production of what? Of ammonium tetrasulfate acid. That ammonium tetrasulfate rather is used for what? For making fertilizers. It's used for making fertilizers for our farms. So you know what fertilizer is used for? To grow our plants so that they can grow faster and bigger. The next one is what? Is coke. Now coke is the only substance of destructive distillation of coal that is left after the remaining three, which are ammonium liquor, coal gas, and coal tar. After they have escaped, the only one that is left is what? Is coke. And coke is a light porous what? Black carbon. It contains what? 90% of what? Amorphous what? Carbon, and it can be used for the production of what? Ethene. This is the reaction when you what? You combine calcium and what? And coke together. You are going to get what? Calcium carbide. Then the calcium carbide will be what? Combined with water to get what? Calcium hydroxide. Then you have your what? You have your ethene. You have your ethene. Now, your coke is used for the extraction of what? Of metals from their ore. You use them to extract metals from their ore. From their ore. Now, metals like zinc oxide, iron oxide, copper oxide, and what? Lead oxide. Use them to, now, a good example is what? You want to extract zinc from its oxide, from its ore rather. Then you combine it what? With coke. Then you have what? Zinc extracted. Why carbon dioxide what? Is a gas to lead the reaction. So this is what? This is the destructive distillation of coal. Don't forget that destructive distillation of coal is a process by which we get 4 products from coal after subjecting coal to what? To heat of about 1250 degrees Celsius. These products are what? Ammonical liquor, coke, coal gas, and coal tar. And apart from coke, which is what? Non-volatile, the remaining 3, which are ammonical liquor, coal gas, and coal tar, they are what? They are a volatile substance. They leave the reaction and what? And will be collected at different temperature. The next thing we'll be talking about is gasification of coke. Gasification of coke. What is the meaning of that? By the time we subject it to coke, it brings out some gases. And what are these gases? They are, number 1 is a producer gas, number 2 is what? A water gas. And coke can be converted into gases by making it combine with either oxygen or air, or oxygen of the air, or with what? With steam. When coke is being combined with oxygen of the air or steam, it gives out some gases. Number 1 is what? Producer gas. Now, producer gas is formed when air is passed through what? Thick layer of what? Of red hot what? Coke. And this is it. Look at this air, oxygen gas and what? Nitrogen gas. When they combine with what? With coke, we have what? We are going to get 2 volumes of what? Carbon dioxide, and what? And 4 volumes of what? Nitrogen gas. Now, this reaction is exothermic. What is known as exothermic reaction? Any reaction that what? That gives out heat to the environment is what? Is exothermic. This reaction is what? It gives out heat to the environment. So now these 2 volumes of carbon dioxide and 4 volumes of what? Nitrogen gas. Both of them together, they make up what we call a producer gas. They make up what we call a producer gas. And now they combine. A producer gas consists of carbon dioxide and the nitrogen gas in the ratio 1 to 2, because for producer gas to be produced, there must be 2 volumes of what? 2 volumes of carbon monoxide, 2 volumes of carbon dioxide, and what? And 4 volumes of nitrogen gas. So these 2 gases, they combine in the ratio 1 to what? 1 to 2. The next one is what? A water gas. Water gas is formed when steam is blown over white oak precipitate, over white hot coke rather, in a what? In a furnace. Now the furnace must be 1000 degrees Celsius hot or more, or about 1000 degrees Celsius hot. Now when you what? You do this, you are going to get a what? The water gas. The concept of a water gas are what? Carbon dioxide and what? And hydrogen gas. These 2 forms what? Carbon dioxide. Can you see ratio 1 to 1? In ratio what? 1 to 1. But that of a producer gas is ratio 1 to 2. Now this reaction is what? Is endothermic. That is, it absorbs heat from the environment. It absorbs heat from the environment. That of a producer gas is what? Is endothermic. It gives out heat to the environment. So this is what? The production. Look at coke. You have the coke, and this water gas, and this is what? This is our producer gas, and this is our water gas. So properties of carbon. Number one is what? Combustion. That is burning in air. When carbon burn in air, they give out what? They give out carbon dioxide. That is when the air is what? Is in excess. They burn completely to give what? Carbon dioxide. But in the limited supply of air, they give carbon dioxide. Another reaction or properties of what? Carbon is what? Combination reaction. That is, carbon can combine directly with some elements at high temperature. Some elements like hydrogen, sulfur, aluminium, and calcium at high temperature. Now, when carbon combine with hydrogen, they give what? Methane. When carbon combine with what? Sulfur, they give what? Carbon 4 sulfide. Another properties of carbon is what? Is as a reducing agent. They reduce what? They reduce some oxide of less reactive metal at what? At high temperature to their metal, and what? And steam to hydrogen. Look at iron oxide with carbon to give what? To give iron. The next one is what? With a strong oxidizing agent. That is, when carbon reacts with hot concentrated H2SO4 or HNO3, it is oxidized to what? Carbon. They give carbon dioxide. That is, when carbon reacts with what? With oxidizing agent, they give out what? Carbon dioxide. Look at an example is what? Carbon with what? H2SO4 to give carbon dioxide. They give this. The next one is what? Carbon with what? HNO3 to give what? Carbon dioxide, another product, and water. Now we want to look at the oxides of carbon. The first oxide of carbon we are going to look at, which is very, very important and found everywhere, is what? Is carbon dioxide. It's carbon dioxide. Carbon dioxide is a product that is very important to plants, because they have to take it in so as for photosynthesis to occur. Because without carbon dioxide, the food of plant cannot be what? Cannot be produced, which is starch, cannot be produced, because it is the reaction between the carbon dioxide, the water, the enzyme, and sunlight, which makes what? Photosynthesis to occur, so that they can produce what? The glucose which plant needs, and what? And water is what? And carbon dioxide and oxygen rather is given off. Now, carbon dioxide is what? Is abundant. Is abundant in what? In the environment, and it is from the environment that what? That the plants will take it, so that they can make use of it. Now, for carbon dioxide to now what? To now be produced in the laboratory, when you react dilute HCl, hydrochloric acid, with what? With marble chips in the laboratory, we can get what? We can get carbon dioxide. We get carbon dioxide, and it can be collected in two forms, either through what? Upward delivery, or what? Or downward delivery. What's meaning of that? You collect the carbon dioxide in what? Upward or downward displacement of what? Of air. This is upward what? Upward delivery. The carbon dioxide is going upward, but here it is what? Downward delivery. The carbon dioxide is being delivered into this downward, in a downward form rather. So you are going to have what? Dilute hydrochloric acid being reacted with what? Marble chips to have this. Now, in the downward delivery, you have to what? Put a fused calcium chloride here. A fused calcium chloride. So you react a dilute hydrochloric acid with what? With marble chips in a U-tube. In that U-tube, you have what? You have a fused calcium chloride. Then you are going to get what? Carbon dioxide. This is through what? A downward delivery, and this is through what? Upward delivery. Now, other methods through which you can get carbon dioxide is one, fermentation of glucose. When glucose ferments, we are going to what? Have what? Carbon dioxide. That is, this can be found in what? In anaerobic respiration. Anaerobic respiration, that is breakdown of glucose in the absence of oxygen. Yes, to give alcohol and what? And carbon dioxide. Then you have energy. The next one is what? Thermal decomposition of what? Of marble. When marble is being decomposed, you have what? Carbon dioxide and what? Calcium oxide. The next one is what? Combustion of hydrocarbon. When hydrocarbon burns, what hydrocarbons, like your petrol, your kerosene, your diesel, when they burns, they give out what? Carbon dioxide. An example of hydrocarbons, methane, burning oxygen to give what? Carbon dioxide. The next one is what? Reduction of metallic oxide by carbon dioxide. Carbon dioxide reduce what? A metallic oxide to give what? Also carbon dioxide. Now we move on to physical properties of carbon dioxide. Number one is that it is colorless and odorless. It's colorless, it's odorless, and it is tasteless. It is slightly soluble in water, not totally soluble in water, but slightly soluble in water. It is a weak acidic gas. It's a very weak acidic gas, and this weak acidic gas can turn wet or moist litmus paper, which is blue, to red. It can turn it because it is an acidic gas. The next one is that on cooling, it liquefies and what? And solidifies at minus 78 degrees Celsius to form white solid known as dry ice. This dry ice is very, very, very important. Very important. It can be used as cooling agent. Dry ice can be used as a cooling agent. The next one is what? The chemical properties. Reaction with burning magnesium. Carbon dioxide will continue to burn. Magnesium will continue to burn in the presence of carbon dioxide. In the presence of carbon. The next one is what? Reaction with water. Carbon dioxide will react with water to form triisocarbonate 4 acid, which is a very weak acid. This acid is what? Is weak. The next one is what? Reaction with alkali. Carbon dioxide will react with alkali to form triisocarbonate 4 and what? And water. Then the test for carbon dioxide is that when you introduce carbon dioxide into a container that contains what? Lime water, the lime water will turn to milk, a milky color. That is to tell you that that container contains what? Carbon dioxide. That is, carbon dioxide turns lime water milky. What are the uses of carbon dioxide? The first use of carbon dioxide is that carbon dioxide is a very good product for fire extinguisher. We have a fire extinguisher contains what? Carbon dioxide. It can be used to quench or extinguish fire. The next one is that carbon dioxide and water can form or form sweet taste. Now, when you look at the cork of either Coke or the label of Coke or Fanta, you are going to see carbonated drinks. This carbonated drinks is from carbon dioxide and water. They have a sweet taste. They can be used to make mineral water like your Sprite, your Coke, Fanta, and so on. Now we have solid carbon dioxide also is used as cooling agent. That is dry ice. The next one is what? Green plants make use of carbon dioxide to produce their food. Without carbon dioxide, green plants cannot produce their food, which is starch. If we can remember very well, photosynthesis, carbon dioxide and water in the presence of sunlight are being trapped by what? Chlorophyll with what? Enzyme to produce what? Starch. Without carbon dioxide, green plants cannot produce their food. Next one is what? Is carbon dioxide can be used as a leavening agent in baking of what? In baking of bread. That's why it is used in what? In a Sauvé process. What is a Sauvé process? In Sauvé process gives what? Gives sodium hydrogen triisocarbonate. Sodium hydrogen what? Triisocarbonate. That is what? The product of a what? Sauvé process. The next one is what? It is used in what? In nuclear reactor as a coolant. That is, those are the units of what? Of carbon dioxide.